So, are you ready to be John Napier here? We're going to use some properties of logarithms to multiply, divide, and take powers of numbers. So this first question, use the product property to multiply 627 by 726. Okay, so before we even start, let's take a look at the log table. Now, I know that the numbers here, you can't see them too well because they're so small, but I just want you to understand how to read the log table. And speaking of log table, we know that this is specifically common log, as in base 10. So, for example, if I am trying to look up the log of, I don't know, let's say 1.3. Come on, there we go, 1.3. I look over here on the left-hand side, there's 1.0, 1.1, 1.2, 1.3. So it's this number right here, 1.3, and if I look across the top, it gives me some additional decimals, gives it to me in the hundredths place. So the first one there is 0.114, so that's equal to 0.114. What does that mean? That means 10 to the 0.114 power is equal to 1.3. Okay? That's how we read the log table. Now, if I wanted to work backwards from this, if I wanted to find, like if I had a power of 10 and I was trying to find out what the answer was, let's just say that I had 10 to the point, these numbers are pretty hard to see. I'm going to go with 0.479. 0.479. I go backwards here. 0.479 is right here. 0.479, the answer to that is 3.0, and then it is in the second column, so it is an additional 1/100th there, so it's 3.01. Okay, so now that we've gotten that out of the way, let's go back to our original problem here. So instead of just simply multiplying 627 times 726, what I'm going to do is I'm going to use this log property here. And again, this is log base 10, so it's common log base 10 using the table here. And I'm just going to go ahead and I'm going to take the log of this. Okay, so now taking the log of this product, I can use the product property to break this up in a sum. And that's the whole point of this is to turn a multiplication problem into an addition problem, because adding is faster and easier than multiplication. So this turns into the log of 627 plus the log of 726. Okay, so now we're about to run into another problem. If I look back at this log table again, notice that all I have are the numbers 1 to 4.9, 5.49, and 5.5 to 10. So in other words, I can only go from 1 to 10 on my log table. So here's the trick. We're just going to turn each of these numbers into scientific notation. We're going to write this as the log of, and in parentheses here, 6.27 times, I'll put that as an x, times 10 to the second, right? I just wrote it in scientific notation. Move the decimal place over 2 places. Plus the log of 7.26 times 10 to the second. Okay, so now I get to use the product property again, because inside here I have another product. So I'm going to rewrite this as the log of 6.27 plus the log of 10 squared plus that's a plus sign, the log of 7.26 plus the log of 10 squared. Okay, so now we're almost good to go. I have to now look at my table and try to find the log of 6.27. Okay, so I have this set up for us already. So let me just fast forward here. So 6.27? Yeah, 6.27. So I look at 6.2 right here. There's 6.2. So I'm going to highlight that whole entire row. Okay, so 6.2, and now I'm going to look at the 0.07 column. Just follow it down, and where these two rectangles meet, that is the log of 6.27. So that's 0.797. 0.797. So the log of 6.27 is equal to 0.797. So let me go back here. This is equal to 0.797. I hope that's what it was anyway. Okay, what about the log of 10 squared? Log of 10 squared, that's the same thing as the log of 100. What we're asking ourselves is 10 to what power is equal to 100? That's 2 plus 2, right? We could have gotten that just from the exponent there. Okay, so now let's go to the log of 7.26. Again, I have this set up for us. The log of 7.26. So 7.2. Now I'm going to highlight that whole entire row, 7.2. And now I need the 6th column, and the 6th column is right here. Remember, this goes 0, 1, this is 0, 1, 2, 3, 4, 5, 6. So the 6th column. So where these two intersect is 0.861. So the log of 7.26 is equal to 0.861. 0.861. 0.861. Okay, and then finally plus from this one another 2, plus 2. Okay, so let's just keep adding. So the 2 and the 2, that part's easy. That's equal to 4. And now by hand, I have to add these two decimal numbers. Can't see it, but there's a beetle crawling around on my floor. Okay, anyway, so let's, over here on the side, let's add 0.797 and 0.861. And I know a lot of you are freaking out about like actual addition without a calculator, but you can do it. So 7 and 1 is 8, 9 and 6 is 15, carry the 1, and another 15 plus 1 is 1.6. Okay, so plus 1.658. Okay, and now just add that, and I get 5.658. Okay, now what do we do with that? This is an answer to a logarithm, which means that it is an exponent. It's an exponent on what number? It's an exponent on 10 to the 5.658 power. Okay, so we're almost there. We're almost there. But we're about to run into another problem. Because remember when we said when we're looking backwards, when we're trying to find an actual power of 10, if I look at these numbers, I start at 0 and I go all the way to 1. There's no way for me to get 5.658 from this table because it only goes all the way up to 1. So here's the next trick. This is equal to 10 to the 5th times 10 to the 0.658. because whenever you multiply with like bases, you add the exponents, and 5 plus 0.658 is this original exponent here. So basically what we're going to do is we're going to get our answer in scientific notation. So here is the number that I want to look up backwards in my log table. Okay, so I have this set up for us as well, and it is right here. So we're looking for 0.658, which I've highlighted here in this little rectangle. So now in order to read it off, it is in the 4.5 row, and this is, remember, 0, 1, 2, 3, 4, 5. And then we also had that 10 to the 5th power, so you can move the decimal place if you wanted to, or you could just leave your answer like this. This is perfectly acceptable. Let's just go ahead and move that decimal place over 5 places. So here I moved it over 2 places. I need 3 zeros on it, so it's 455,000. And finally,